Hello, today we are going to look at the Peltier Air Conditioner, and we want to look at the maximized efficiency, and we can use it to cool a variety of rooms. And here we have the smallest and compact air conditioner, which uses the Peltier effect, where you pass current through a thermocouple element. It produces a hot and cold side, which eventually also lead to cooling effect. So one side becomes hot and the other side becomes cold. So by interchanging the polarity of the thermocouple, you can be able to change the flow of the heat. Either the cold side now becomes the hot and the hot side becomes the cold. These thermoelectric modules are capable of doing pretty good work. Also, you can apply heat to get electricity, but here we are concerned about the production of cooling effect. So currently what we are going to look at is that we want to maximize the efficiency, because their COP ranges from values between 0.13 to 0.2, and therefore we can be able to increase this. So by choosing the correct power supply and also successfully removing the heat by the use of this thermal heat fan and fins, you can be able to remove plenty of good heat from the hot side, so to keep the temperature difference at a maximum as possible. So this is the work, and if you do that by use of a good designer and modeling, you can be able to fabricate and be able to get a very conducive air conditioner with a performance of 2.5, like the ones that we are using currently. It is 2.5. It has been optimized. This is the power supply. It uses 12 volts, 10 amperes, because it's TEC 12710. So it draws 10 amperes, and it has 127 couples in a single module. So you're going to have one module. So this power supply is able to convert AC to DC. So it's a converter capable of 24 volts and 12 volts. Currently we are in automatic mode, so it will run on 12 volts and supply 10 amperes. So it takes plenty of juice here. And also look at the wiring here. You need to look at the number of wires here. They should be larger size, like here we've used diameter 1.5 and gauge 14, so that because we are having a lot of heating here. So we have the fans, which are able to circulate the air. This is the interior view, and here is this is the Peltier, which is connected to the cold side heat sink. We have the temperature probe for measuring the temperature. We have the forced convention heat pipes with the copper heat pipes, and aluminium heat sinks with the thermal resistivity of 0.1. And here we have the push buttons for on, fan mode, and also here we have got the thermostat for temperature control. Let's just run her and see how she does. So push here on, and she comes on. The temperature currently it's 20 degrees, so this is the hot side, the hot range temperature, and this is the cold temperature. So when it reaches 14, it will be able to trip. So we give it time, we'll be able to see the temperature change. Temperatures continue to drop drastically. We are now at 16 degrees Celsius. You put here your hand. We are now at 15. Put here your hand. It's very cold. Peltier has cut the power supply. Temperature is continuing to drop up to 9 degrees Celsius, 8. She's at 8. Power supply. This is how the thermostat works. So this is how the thermostat works. At 14 it will be able to cut the power supply, and at 13 above 18 degrees Celsius it will be able to come on. So this is the basic principle of operation of the thermostat. Also in this air conditioner we will be able to look at various modes of operation. So if we press here, we'll be able to activate only the fan, so the Peltier won't be able to cool. So it has stopped, so it won't be able to cool. It will only be performing air flow around the room. Sasa this is how the air conditioner is working. So the power supply is here and everything is now here. It's really cold down here. It's really the temperatures are really dropping here. So this is all about this kind of air conditioner that we have looked about.